Okay. So today we're working on similar figures. And similar figures are basically similar to what we were doing yesterday, thinking about models and a smaller version or a bigger version of different things. What we have here is two triangles, and this one is basically a bigger version of this one. And that's what makes them similar. And what makes them similar is these lengths, this 4 and the 7 and the 21 and the x, are all in proportion to each other. That is what makes a similar figure in relationship with the other similar figure. So it's all about proportions. So we're going to use proportions to help us solve for this unknown value. And if you haven't written down these triangles, go ahead and do that. You can pause the video and make sure you have these first notes down. So when it comes to similar figures, it's all about corresponding sides. We want to make sure that our sides are lined up. And to make it easy on ourselves, especially the first time we're doing that, I'm going to draw just a template triangle, and I'm going to label it base and side. So these are going to be my corresponding sides. Notice that both of these have a base. This one's 7, this one's 21. And both of them have a side, 4 and x. And we really need to keep track of those corresponding sides to help us solve this problem. Now, what's interesting about similar figures is that there are two ways that we can set up our proportion. I'm going to go over both of those ways today. And that's why it was so important to label these corresponding sides so that we can keep track of everything. So the first way, the first model that we're going to use is side over base. Just like with our word problems, this is going to be our template that we're going to use to fill in our proportion based off of this ratio, side to base. So let's take this first one because both values are given here. The side of this one is 4. The base of this one is 7. So let's write that, 4, 7. Side to base. And that's going to equal the side to base over here for this one. And the side of this triangle, we don't know it yet, that's x. And the base to this one over here is 21. There's our proportion. Again, the hardest part of these proportion problems is setting it up correctly and making sure that our sides and our bases are all corresponding. We don't want them flipped around. That would mess everything up. So after we have our proportion set up, we'll look for the ratio, the relationship. Is there a relationship between 7 and 21? Yes, there is. I'm going to multiply by 3. There's my magic number. 7 times 3 is 21. We're going to apply that same method up here. 4 times 3 is going to give us x, and x is going to be 12. So there's our missing side right up here. And normally I would like to include units. I'm trying to go easy on you guys and not include units right off the bat, but units may be included in some of these problems in the future. But for now, let's not worry about units. So my missing side is 12 units, whatever that is. Could be inches, centimeters, miles, anything, we don't know. So we're just going to keep it as is. So that's one way that we can solve these sort of problems, is compare the base to the side. Another way is we can do side to side equals base to base. This one's a little more complicated. Or it might not be. This one might vibe with you a little better than this one over here. So what am I talking about here? Well, the sides, I know that I've got a side here and here. So I'm going to compare this side to that side. That's going to be my ratio. So I'm going to set that up as 4 over x, side to side. Now, we're going to do the same thing over here, base to base, but it's really important that we keep that order the same. We're going to start with the small triangle, the base over here, and we're going to compare it to the base of our bigger triangle. So that's going to be 7 to 21. So just to make sure that we're on the same page here, I've got 4 to x, those are my sides, 7 to 21. What I'm looking for here is that the numerators are my first triangle, 4 and 7, and my denominators are x and 21. Now you could flip the order if you wanted to, but you just have to keep it all consistent. So at this point, here's my ratio, and I need to solve for x. Right off the bat, I'm not seeing a relationship between my known values, 4 and 7. But what I can do, I could do the reciprocal and flip it all around and solve for x algebraically. I could also look at this 7 over 21 and think, could I reduce this at all? Is there any number in common that I can divide the 7 by and the 21 by? And yes, you can. You can divide by 7. So I'm going to rewrite my proportion with a reduced ratio on the right side. 4 over x equals 7 divided by 7 is 1. 21 divided by 7 is 3. Ooh, now I've got a nice relationship over here. And it's a little bit different because normally my x is over here on the right side, but now it's on the left. That's okay. I'm still looking for a relationship. I could divide 4 by 4 and get 1, but that's not going to help us down here. We don't know what we're going to divide this by. So instead, I'm going to reverse course, and I'm going to say, hey, what number can I multiply 1 by to get to 4? And that number is going to be 4. I'm going to apply that same relationship down here in my denominator, times 4. 3 times 4 is 12, and there's my value for x. And you'll notice that's the same thing that we got when we did our side to base comparison. So again, for these type of problems, it's a little confusing because there's more than one way that you can take these. But as long as you're being consistent and you are comparing the corresponding sides and not flipping the order around, you're going to get these right. That's it. Thanks. Mm-hmm.